All right, so we're back, and we're still talking about probability. We want to continue to talk about how to calculate probabilities of combined events. We've previously talked about how to combine events using the AND or the OR operation. We've also talked about how we can calculate probabilities of those combined events if the outcomes are equally likely. And we can do that just by determining how many of those outcomes lie in the combined set. Today we want to talk about special cases where we can determine the probability of the combined event by only knowing the probabilities of the individual event. So the first kind of paired events we want to talk about are called mutually exclusive. And we say that events A and B are mutually exclusive if they have no outcomes in common. Another way of thinking about this is that the set or the event A and B is what we call the empty set, meaning that there's nothing in there. And so that means that if you go through the list of outcomes that are in A, you'll find none of those in B, and vice versa. If you go through the outcomes that are in B, you'll find none of those in A. So, for example, continuing with our six-sided die, we have a sample space that involves rolling a 1, 2, 3, 4, 5, or 6. We can define events A, which is rolling a 1 or a 2, and we can define an event B as rolling a 5 or a 6. And then we can see that these two things are mutually exclusive. 1 appears only in A, 2 appears only in A, 5 appears only in B, and 6 appears only in B as well. And so we can calculate the probabilities of A and B because rolling a six-sided die, we're going to assume those events are equally likely. So since there's 6 outcomes, each outcome has a probability of 1 out of 6. And so the probability of A here would be 2 out of 6 or 1/3. And our probability of B would be 2 out of 6 as well, or 1/3. So this, we have mutually exclusive events, and we want to ask what is the probability of A or B. And so we get the rule that says that if A and B are mutually exclusive events, then the probability of A or B is just equal to the probability of A plus the probability of B. So in this particular example, we can get that the probability of A or B is equal to the probability of A plus the probability of B, which in this case is equal to 1/3 plus 1/3 or 2/3. And we can check that by saying, well, what are the outcomes that are in A or B? Right? If I say A or B, and just write down what's in that event, that's 1, 2, 5, and 6. And so using our previous method of calculating probabilities, we would say that the probability of A or B is equal to 4 out of 6, or 2/3. But now let's take a minute and look at why the mutually exclusive part of this is so important. Okay, now let's define two different events, A and B. Let's define the event A to be getting a 1, 2, or 3. And let's define B as being the event of getting a 2, 4, or 6. So event A is rolling less than a 4, and event B is rolling an even number. Then, because each of these have 3 of the equally likely outcomes, we get that the probability of A is equal to 3/6, or 1/2. And the probability of B is also 3 out of 6, or 1/2. They're also not mutually exclusive. Right? We can see that 2 is in both A and B, so these would fail our definition of mutually exclusive. And if we tried to just blindly apply the mutually exclusive rule and say, well, the probability of A or B is equal to the probability of A plus the probability of B, then we would get that that is equal to 1/2 plus 1/2, which is equal to 1. And remember, an event that has probability of 1 is an event that's guaranteed to happen. This is an event that no matter what, this will occur. And if we look at what is in the event A or B, then the event A or B in this case is we have 1, we have 2, we have 3, we have 4, and we have 6. And if we count up our outcomes here, we have 1, 2, 3, 4, 5 outcomes. And so using that, we would get that the probability of A or B is equal to 5 out of 6. Right? A or B does not include 5. But over here, this says that the probability of getting A or B is equal to 1, which means that the probability of rolling a 5 has to be 0. But we said that these were equally likely, that 5 has to have the same probability as all the other outcomes. And so if 5 has to be 0, then all of them have to be 0. And if all of them are 0, then that means that there's no chance that when we roll a 6-sided die that we get 1, 2, 3, 4, 5, and 6. So what's going to happen when we roll that die? So if we don't pay attention to applying the rule to only mutually exclusive events, we can lead to results that make no sense. And so we have to make sure that we're applying rules in appropriate situations. So we're going to talk next time about a different kind of special case. But before we do that, one last thing about mutually exclusive events. If you have two events that are mutually exclusive, A and B has to be empty. It means there's no outcomes in there. So in addition to knowing that the probability of A or B is just the sum of the individual probabilities, this tells us that the probability of A and B has to always be 0 for any mutually exclusive event. Until next time.